Hello, my name is Mohsen and I'm going to talk about chemical kinetics, rate of reaction and also iodine clock, which is a kind of chemical kinetic. Today we're going to learn about chemical kinetic, first order reaction, iodine clock, the limiting reactant in iodine clock, stoichiometry and calculating the rate of reaction. So anybody know anything about these subjects? Do you think why they are important, how we can use them in the future? So let's explain for you. Chemical kinetics is very important for many industries. Many businesses trying to have most benefit in the lowest time. So rate of reaction can identify how long a reaction gonna be take. I can remember when I worked as a quality control technician in one of pharmaceutical company, my manager asked me to find the best solution for rising the speed of that reaction, which was for generating a tablet. So I referred to previous articles. I could find the kind of reaction which was first order and also the main important factors for increasing the rate of that reaction. The main factors will include concentration, pressure and temperature. I gave these important information to my manager and made him so happy. Chemical kinetics is a branch of physical chemistry. It's a study about rate of reaction. It's very important to know why some of reactions occurs in less than a second and the other one can take for a day, for a week, or even more than that. So it's very important to know about the main reason of that. The rate depends on a particular concentration. For example, let's say we run a reaction several times with different initial concentration to see what it does to rate. If we keep everything else the same, but we double the concentration of just one reactant, so for zero order, it doesn't affect on the rate of reaction. For first order, it can make double the rate of reaction. And for second order, it can make it 4 times greater. So the kind of reaction can affect on the rate of that. Iodine clock is one of kinetic reaction. It's first order reaction and the rate of reaction linearly depends on just one reactant, which is potassium iodine. Iodine clock is where 2 colorless solutions are mixed and after a certain period of time a sudden color change occurs. There are many variations, but today I will explain about potassium iodine hydrogen peroxide variant. Chemically, iodine clock include 4 different equations. But let's start from the second one, which is the slowest, and because of this, it's rate determining step. Iodide reacts with hydrogen peroxide to create iodine. As soon as iodine is formed, it reacts with sodium thiosulfate to regenerate iodide ion. So basically, in the second equation, iodide can create iodine. As soon as iodine is formed, react with the sodium thiosulfate and again regenerate iodide ion. So again reduce back to the iodide. The conversion between iodine to iodide is so fast. And because of this, it effectively keeps the concentration of iodine around 0. This back and forth conversion between iodine to iodide occurs until all sodium thiosulfate are exhausted. In this case, iodine can reduce back to iodide and will start to build up. Referring to the first equation, iodine, which we have it now, can react with the rest of iodine to create triiodide. In the last equation, triiodide react with the starch to create starch pentiodine complex, which has characteristic blue-black color. So in this reaction, the rate of reaction linearly depends on just one reactant, which is iodine or potassium iodine. Also, sodium thiosulfate is limiting reactant. So the concentration of limiting reactant can alter how long it takes iodine back and forth to iodide. Therefore, we can control how long a reaction gonna be take to be blue-black color. So in conclusion, so far we learned kinetics. Why kinetics is important in the future? Iodine clock reaction. And why the rate of reaction is very important in iodine. Thiosulfate, which can play important role in the iodine clock reaction and play as a limiting reactant. The rate of reaction, which is first order, and potassium iodine, which can change the rate of reaction. Okay, let's start to explain about the experiment now. For this experiment, we need to have 5 different groups. Each group includes 4 students. For this experiment, you need to create 2 different solutions, solution A and B. For solution B, add 1.6 grams of starch, then put 500 milliliter, half this amount, to the starch, mix them with stirring and heat it up until the solution becomes clear. Cloudiness indicates undissolved starch, so keep heating and stirring until you see the clear solutions. Once solution becomes clear, add 50 grams potassium iodide, 4.1 grams anhydrous sodium acetate, followed by sodium thiosulfate, and top this up with 500 milliliter water. Label it as a solution A and mix them together thoroughly, and solution A is ready. Solution B is much easier to make. We just need to pour 500 milliliter 3% hydrogen peroxide, 30 milliliter glycerol acetic acid, 470 milliliter deionized water, mix them together thoroughly, label up as a solution B, and solution B is ready now. Take 50 milliliter solution A and 50 milliliter solution B. Choose a suitably large container, mix them together, and as soon as mixing, one of you responsible to record the time with the clock watch to see how long gonna be take a solution becomes blue-black color. Then create half concentration of solution A and solution B by adding 25 milliliter solution A, 25 milliliter water, same for B, mix them together thoroughly, and then again record the time to see how long gonna be take to see this color. You need to report these times in your lab report and also mention why it happened and what's the effect of concentration on the rate of reaction, and also how is the effect of the concentration on the speed of that reaction. So you need to just write the lab report individually and submit it by next week. Also, each group is responsible to report 2 rates of reaction to me for both concentration. Let's explain about the rate of reaction now. These reactions is stoichiometry. Stoichiometry is a section of chemistry that involves using relationship between reactant and product in a chemical reaction to determine desired quantitative data. We have concentration of sodium thiosulfate. We know sodium thiosulfate has been exhausted. There is no more in the solution. As soon as exhausting sodium thiosulfate, we have iodine in the solution. So sodium thiosulfate is twice than the concentration of iodine. Also, the concentration of iodine in the second equation is exactly the same as the concentration of iodine in the first equation. In this case, finding the rate of reaction is so easy. You just need to know the concentration of iodine divided by total volume solution divided by time it goes to solution become blacks in two different concentrations. You need to report two different rates to me. After reporting the rate of reactions by 5 groups, I will present the answer by showing two different colors. Green color represents the correct answer and red color represents the wrong answer. A first group can report the correct answer for both concentration, will get mark, will get a point, and it can affect on their lab report mark. But they are responsible to help the other groups to find the best solution, to find the correct answer, by not giving the just actual answer to them, also helping and advising them to find the best solution to get the correct answer. For this experiment, goggles and gloves are mandatory. Also, you should know that the acid is using in this experiment can react with sodium thiosulfate to release a toxic gas. Also, hydrogen peroxide is irritant and acetic acid can cause chemical burn. So expect all of you do all parts of experiment under fume cupboard. Also, each student responsible to fill in the cost risk assessment. In this case, I'll provide the laptop on your table, so you need to back to your table and also go to Sigma website, fill in this cost risk assessment form, and then back it to me. Once you fill in this cost risk assessment form, after 10 minutes, you can start your experiments as a group. But this part is individually. References can help you for your calculations, also for finding best answers for your lab reports, and also for your cost risk assessment form. So expect all of you use these references. So if you have any question now, I'm very happy to answer your questions. Otherwise, I would say when you done all of your experiment parts and before leaving the laboratory, I provided some cards for you. In green card, you can mention what you like about this lecture. In red card, you can mention how can I improve myself for the next session, for the next group as well. So I can use your feedbacks to improve myself as well. So in this case, if you have any question, I'm very happy to answer that. Otherwise, you can start your experiment. Thanks very much. Thank you.